Welcome to lesson number 4, exploring functions with the aid of graphing calculators. Now that we've seen in lesson 3 how to combine algebraic expressions that contain constants and variables and exponents using addition, subtraction, multiplication, or division, I'd like to take a closer look at variables, then at functions, and ultimately at how we can study functions better with the aid of graphing calculators. Therefore, this lesson will have 2 parts. 1, the multiple uses of variables, and 2, the use of the graphing calculator in the exploration of functions. Let's look at the 5 following equations. You're going to see them one by one. They will come up on graphics, and we will try to find the differences among these 5 sets of equations. They all have an equal sign, and they all have one or more variables. What I'd like you to learn at the end of them is to distinguish the use, the role, the meaning of the variable in each equation. Here comes the first one. In this first one you see A equals 1/2 BH. The second one you see V minus E plus F equals 2. And the third one you see V equals pi r squared H. Now, those might be familiar equations. They might not. What would you call those 3? You're probably saying it as I'm asking it. Those are formulas. The first one, A equals 1/2 base times height, is probably something you know, the area of a triangle. Let's look at our geoboard in our mathematics laboratory and explain why the area of a triangle is 1/2 base times height. Here we have a triangle. This is the base. The height we can indicate with this rubber band. That would be the height. And why is the area of this triangle 1/2 base times height? Well, if I were to place a rectangle around this triangle, and you can always place a rectangle around any triangle, we know that this height is also this height. Well, then height times base, or base times height, is the area of the rectangle. So that's clear. Now the area of the triangle is 1/2 of that rectangle that contains it. I think you can see why, because this triangle here equals this one here, so this is half of this square, and this is half of this rectangle because this triangle equals that one. So if this is half of this, and if this one is half of this, then the whole triangle is half of the entire rectangle. The second equation on that first graphic has to do with V, the number of vertices, E, the number of edges, and F, the number of faces on a polyhedron. This happens to be a dodecahedron. This is an icosahedron, 20 faces, 12 faces. There are many such polyhedra. If you were to count for each one of these, the regular ones and the irregular ones, the number of vertices, the number of edges, and the number of faces, they would relate according to that equation. The total number of vertices, V, minus the total number of edges, E, plus the total number of faces, F, will always equal 2. That's a fascinating equation discovered by the Swiss mathematician Euler not long ago. It was about the 18th century. The third equation in that first graphic was V equals pi r squared H. Well, you might know that pi r squared is the area of a circle. So it could be the area of the top or the bottom circle. And then if I multiply by H, which is the height of this cylinder, I would get the volume of this cylinder. So those 3 equations are really formulas, and those letters or variables in there really are labels for height, base, vertex, edge, face, whatever the quantity we are measuring. So those are formulas, and though they have an equal sign, they're not saying solve me. They're not equations to solve. They're just formulas, and the letters are labels. Let's go to graphic number 2 and look at a different set of equations that also use variables in a different way. The first one is x plus y quantity multiplied by quantity x minus y, and we get x squared minus y squared. And b is tangent x equals the quotient of sine x divided by cosine x. Now there, you have x's and y's. The first equation is an identity. Well, we have seen in lesson number 3, the previous one, 3 such identities, which I told you must remember. And the second one, which you might not know yet because you might not have taken trigonometry, but you will, tangent x equals is defined by sine x over cosine x. That's how it's defined. Well, in these two equations, we can think of them as identities or definitions, and x stands for a generalized number. Let's be more specific, a generalized real number. That means for any x belonging to the real number set, those equations hold. Generalized number. It stands for any number. But again, these equations are not to be solved. They give us some information. That's it. Graphic number 3. The first equation, x plus negative x equals 0. Second equation, x times 1 over x equals 1, provided x is not 0. And the third equation, x squared greater than or equal to 0. Well, those equations you understand. The first one says that any real number x added to its additive inverse, or its opposite, will give 0. 3 plus negative 3 gives 0. The second one says any number other than 0, any real number, multiplied by its multiplicative inverse, which we call its reciprocal, equals 1. For example, 2 times 1/2, 3 times 1/3, 5 times 1/5 gives 1. And the third one says all real numbers x greater than, less than, or equal to 0 will give a square greater than or equal to 0. So if we square a number, we'll get a positive number or 0. Well, those are properties of real numbers. Again, they state something about all real numbers, so x stands for a generalized real number. Any number. You could put a box there and say, I can fill it in with anything. Once again, these are not equations to solve. Ready for graphic number 4. The first equation, 4x equals 20. The second equation, x squared equals 4. Now, mind you, this is just the beginning of the course, so we haven't explored equations and how to solve them, which is why I gave you 2 very simple ones, but these are called equations to solve. That means that the x is being sought for. We're looking for its value. What value of x will make the first equation true, and what value of x or values will make the second one true? In this case, we call them equations. And in this case, the variable is called the unknown, a word we're going to use a lot. So when an equation needs to be solved, we call the variable the unknown until we find it and it becomes known. Let's work these two out on our whiteboard. This, you will see later, is called a linear equation because x has an exponent that is 1, and this, you will also see later, is a quadratic equation because x has an exponent of 2. But we can still solve these even though we haven't seen that yet because they're very simple. I want to find x that will make this equation true. Well, 4 times what gives 20? Well, you've probably already guessed that it's 5. Another way of looking at it is saying I want x, not 4x. This is 4 times what I want, so I can divide both sides by 4 and make it 4 times less. 4 divided by 4 is 1, so that gives me 1x or x equals 5. This is called the solution to the equation. So the unknown becomes known and equals 5. This is an equation that says, what number squared will give me 4? Well, if I were to take the square root of the left side and the square root of the right side, I get x equals plus or minus 2. That means that either 2 squared will work, because that will give me 4, or negative 2 squared will also work, because that will also give me 4. So this equation has two solutions, plus 2 and minus 2. These are the solutions, plural, of that equation. They were unknown until they became known. Let's go to the fifth graphic and final graphic, where we have yet another situation that contains variables. The first equation, y equals 5.50x, or f of x equals 5.50x. B, y equals x squared, or f of x equals x squared. And the third, y equals 1 over x, or f of x equals 1 over x. These are functions, equations of functions. When I put the or there, that's to emphasize that y or f of x are the same thing, which means y equals f of x. In English, that means y is a function of x. Y depends on x. These functions and many others will be the center of this entire course. As you see perhaps on the video enclosure, we have exploring linear functions will be the first section coming up, then exploring quadratic functions, and exploring exponential and rational functions. Well, here we have what you just saw, a linear function, a quadratic function, and a rational function. And if you don't understand all that, that's fine. We're going to take them step by step. But what I want you to understand is that this is a situation, each one of those three, is a situation that implies change. As the value of x changes, so will the value of y. Sometimes y will increase with x, sometimes y will decrease as x increases. Whatever the case, there is variability. Things are changing, there is variability, and that's what really gave the word variable. So when we have a function, we can call x the argument of the function. That's a very elegant term. Or you can call it the variable. But more specifically, since we have two variables, x is called the independent variable. It can take the value you wish within the domain, which we'll see what that means. And y is the dependent variable. It depends on what x is. You can also say that x is the input variable. Y is the output variable. These are words we're going to use. X variable, y variable, input, output, independent, dependent. This is a good place to move to part 2 of this lesson, which is showing how we're going to use the graphing calculator to enhance, to help us in the exploration of functions. So you see here I have the calculator that I'm going to use. It's a TI-82 Texas Instruments. There's the TI-83s that are out now. You might even have the TI-81, which is quite good. And there are many other brands. It's a graphing calculator. We are going to use certain keys pretty frequently. So I thought that in lesson 4, that precedes the sequence of all those lessons where I use this, would be a good place to go over some of the main keys and really show you step by step the keys we're going to use, so that later when you see them coming up and I say push enter or push stat plot or push window, you will know what keys I'm talking about. So the first thing I will do is take those 3 equations that you saw in that last graphic, those 3 functions, plug them in, and then go from there. Here we go. This first row of keys, 1, 2, 3, 4, 5, right below the monitor, is called the graphing keys. We are going to use these very frequently. On the second row, we have this second key, very important. You know that from your scientific calculators. It accesses the light blue section of each key, which is above the key. So we'd have to push second mode to quit. Then we have the mode key, and then this one is the delete and the insert. These help us edit what we've written incorrectly by deleting or inserting a character. And these 4 move the cursors up, down, left, and right. On the second line, or the third line rather, we have another alpha lock. It's a third function, it's just the way second, this could have been called third. Alpha accesses the gray part of each key, which is on the top right. So if we want to access the letter capital A, it's above the math key, so we'd have to push alpha math to get A. We won't use that very often. This key is very important. It says x, comma, t, comma, theta. That's the variable key. Ours will always be x because x is a real number, and we're writing this in rectangular coordinates. So we would not use theta, which is polar coordinates, or t, which is parametric coordinates. This third key here on the third line is the stat key for statistics, and the list above that. We will be using that a lot, and we'll go through that. Finally, the fourth row are menus, the math menu, the matrix menu. We'll use that in one of the last lessons when we study how to use matrices to solve equations. The program key we won't touch, the variables either, and clear is very important. Now below this we have 1, 2, 3, 4, 5, 6 rows of 5 keys, or 30 keys, and these you can think of as being your scientific calculator. So really what interests us is above the scientific calculator, because below you know how to use a scientific calculator. We have the operation signs, we have the digits, the decimal point. The negative sign is very important because when you want to write -3, you have to push this negative sign here below and at the left of the enter key, and not the minus sign. Enter at the bottom is very important. Enter is like equals. Whenever we want something to happen, we push enter, and I'll be saying that a lot also. So let's begin by turning on the calculator. A very important key is the on key in the bottom left corner. And above that you see the off key, which means you'd have to push second on to get off. Here we have a blank screen, which is called our home screen, ready to type. But we won't type anything. We'll go to the first key on our graphing keys, top left corner, and that's the Y equals menu. We have a menu of 10, although only 8 are visible. We would go down with the cursor and go down to Y10. Let's type in those 3 functions you saw in the last graphic. 5.50x. We push enter. The next one is x squared, so you push the variable x and then you push the x squared from the scientific part. You also could have put hat, which is at the bottom or right under the clear key, and then put 2. The hat symbol is the power symbol. Push enter and we go to the third one. 1 divided by x is the reciprocal function, the inverse function. Let's now go to, no, what we can do here actually, since I want to concentrate on the first function first, let's turn off the y2 and y3. This is also important to know how to do. If I put the cursor on the equal sign and push enter, I deselect it. And if I do the same with the third and push enter, notice that they no longer have a rectangle around the equal sign, which means they've been deselected, and when I will graph, only the first one will graph. We can do that when we want to store many functions but only graph them one by one. Let's go to key number 2, window. Very important. This gives you the measurement of the visible window. On the horizontal axis, or the x-axis, the minimum value on the left will be -10, the right will be 10. The scale will be 1, meaning that there will be a little tick mark along the horizontal axis, one of those little marks to mark the units at every 1 unit. If I change the scale to 2, I'd have a tick mark at every 2 values, 2, 4, 6, 8, 10. On the vertical axis, -10 will be at the bottom and +10 on the top, and again the scale will be 1. We won't always worry about the scale, although you can play with that. This window from -10 to 10 on both axes is called the standard window. And there's a way to access that in one push of a button if we want that particular window. If we want to change the window, we'll see how we do that. We just take the cursor, move down, and change the values we want to adjust our window to a larger window or a smaller window where we would zoom in. That brings us to the zoom key, the third key. Let's look at some of the things we have. Again, I'm only going over the ones we'll use a lot. You can explore the others. We'll be zooming in when we want to look at something very closely. We'll be zooming out when we want to see the big picture. Zoom decimal, well, we might not use that. Zoom squared is when we want the x coordinates, the x units and the y units to be the exact same length. Zoom standard, this is what you would push when you would want that window of -10 to 10 on both axes in one push. You would go to zoom, select 6, and then you push enter. And finally, another one that we will look at a lot is the number 9, zoom stat. When we will plot, using the statistical methods they have, data that we will collect, and we'll do this in this lesson and we'll do it in many others, we go to zoom stat, which is number 9 under the zoom menu. Now if we go to graph, we skip trace and go to graph, which is the 5th key to the right of the first line, the last key on the first line. We now graph our line. That is the line y equals 5.50x, or 5.5 x, however you want to call it. And let's trace now. Trace gives you a blinking cursor, which I like to call spider, and it follows the line in the direction you want. If I push the right arrow, it moves it to the right. If I push the left arrow, it moves it to the left. Now let's imagine that this equation gives us the amount of money, y, that you make with each hour of babysitting. Suppose x is 1 hour or 2 hours or 10 hours of babysitting. 5.5 is $5.50 an hour, and y would give you the money that you make. Well, if that's the case, then we're only interested in positive x values, from x equals 0 out to a reasonable number that you think would be the maximum babysitting that you would do in either one day or 1 week or 1 month, whatever. And the vertical axis also would be from 0 to plus infinity or whatever positive number you would select, because you only want to make positive money and not negative money. So let's go back to window, and this is a good chance to vary our window. Let's start with 0 hours, go up to, I don't know, let's say 10 hours, that's fine. Again, the window is, there's no right answer, it's whatever you feel. Y, let's start with 0 money or $0 and go up to 55, because mentally we know that 5.5 times 10 hours will give me 55. Now if we graph, we have the first quadrant. That's how we call this first of the 4 parts that the plane is divided into when we draw the 2 axes. The top right 4th, called quadrant 1, has the property that all points have x coordinates and y coordinates that are both positive. Let's see that. If I were to trace up and down in this quadrant, I get positive x's and positive y's. Notice that the x and the y at the bottom will give you the coordinates of the point where the cursor is blinking. So that's really nice because you can locate your points. Above the window key, we have table set. So let's push second window, get our table set. That will give you the minimum value that you're interested in. We start at x, a minimum of 0, that's fine. And the next one, the little triangle, means delta, and that usually means the increment. So let's put 1 as our increment. so that you look at the money you make with every 1 hour increment. If we want to see that in a table form, a numerical form, we go to table, which is above graph. So second graph gives me table, and here's the reading of those points on the graph, but only with integer values of x, because that's what you put, or we put together. So if we read down, for example, if I go 7 hours of babysitting, I make $38.50. If I want to reset table to look at every half-hour increments, starting with 0 again, the minimum 0 and the increment 0.5, and I go back to table, then I see a half hour, 1.5, in addition to the integer hours. So if you go 4.5 hours, you would get $24.75. Another key that we can look at is the calculate key. That's above the trace. Let's go back to graph. There's our babysitting job graph. Let's go to second trace, which gives me calc. Many things we have here, and we'll look at root, we'll look at minimum and maximum and intersect in future lessons. Let's just try 1, which is value. If I push enter, this is going to evaluate the function at the x of your choice. So if you want to, let's say, to work 9 hours, you push 9, and the calculator will give you not only the y value, the amount of money, but it also gives you the blinking cursor and locates that specific point. Let us go back to the y equals menu, clear this function. You can explore the other two in the same way, so we'll clear those for now. And I'd like to visit one last thing, the stat key. Let's push stat. And edit would be what you would use if you wanted to key in data collected in the class, which you will see me do several times. If I now push edit, in fact, my L1 and L2 lists already have data that I've already keyed in last night. In the first column, we have the measure in centimeters of a shoe size of a person, and on the right is the corresponding length of the forearm from the elbow to the extended middle finger. The question is, after measuring 9 people, is there a relationship, is there a function, is there a correlation between these two values? The first thing we like to do is plot lists. We go to stat plot, and that's above the Y key. Second Y gives me stat plot. My data was in L1 and L2. I actually have 6 lists, so we would turn on plot 1 because they are all off at this point. Let's select 1, turn it on, so we push enter, and we see here that we have the scatter plot blinking. That's what we're going to do. Our X values are in L1 and our Y values are in L2. That's correct. And the mark of my choice is the little square. If I now want to plot those list values, I go to zoom, and here is where I use the zoom stat. Number 9. Pushing enter, it displays those 9 points. This is called a discrete graph because it corresponds to whole numbers and not a continuous graph. If I suspect a line relationship, a linear relationship, and again, I'll do this a lot in future lessons, the calculator has a built-in regression analysis that will find that best fit line. Let's see how we do it. Follow this sequence and mark it down. I go to stat. I go over to calculate. I go down to linear because I suspect a line. And now the calculator is asking me what lists contain the data. Second 1 gives me L1. I put a comma, and second 2 gives me L2. X and Y lists. I now push enter, and there is the equation of the line, which you'll see later, where A is this value and B is that value. This is the correlation coefficient. The closer it is to 1, the better the line fit. If I now want to graph that line, I need to put that into the Y equals menu. So watch this sequence. I want it to come up here, so I push variables. I select statistics. I go over to equation. I select 7 for regression equation, and there is the equation in the y equals menu. I now graph it, and it graphs the line over the data. If I want to trace that line, I need to delete those points, so I go to stat plot off is number 4, and I regraph, and now the line is there, and I can trace it and find the arm length of a person that has this shoe size. Before we close, I'd like you to remember these basic facts. Number 1, that we have 4 quadrants. Quadrant 1, x positive, y positive. Quadrant 2, x negative, y positive. Quadrant 3, x negative, y negative. And quadrant 4, x positive and y negative. And the second, I'd like you to remember that the horizontal axis is called the x-axis or the input axis. And since the y is 0 for every point, it's called y equals 0. On the vertical axis, it's called the y-axis, or the vertical, or the output axis, and since the x value of each point is 0, it is called x equals 0. This was an introduction to the calculator. If you didn't catch everything, don't worry. I will do this and much more over and over again.